To explain my topic, which is net change. At first, I will start by defining my topic and then solve a couple of examples to help further your understanding of this topic. So, the integral of the rate of change of any quantity gives the net change in that quantity. So, for example, velocity. Velocity is the rate of change of distance. So, its integral will give us the net change, which is distance. I know it might sound a bit complicated now, but when we start solving questions, you would understand it even more. So let's solve this question. This is question number 4 in 2017 AP Calculus, AP no calculator. Okay, so let's start by reading the question. The table above gives the velocity Vt in miles per hour of a truck at selected times t in hours using trapezoid sum with 3 subintervals indicated by the table. What is the approximate distance in miles the truck traveled from time 0 to time 3? So, velocity is the rate of change of distance. So its integral will give us the distance, right? But we don't have a function to get here. So we would use the trapezoid sum as indicated in the question. Trapezoid sum, you would follow this rule, where the two functions are the bases, and we divide them by 2 and multiply them by height, which is change in x. Okay, so let's write the integral. The integral will be from 0 to 3 as indicated in the question, and we start by getting each and every subinterval, sum the two bases, divide by 2 and multiply by the height, and we get an answer of 130, which is answer B. Here's another example. Here's an example of a question about net change. This is question number 17 from AP Calculus, AP no calculator. A particle moves along x-axis so that the time t is greater than 0. Its position is given by x as a function of t equals 12 times e to the power of negative t times sine t. What is the first time t at which the velocity of the particle is 0? So we have the distance, and now we would like to find the velocity. So as stated that in the definition I said at first, the integral of the rate of change gives us the net change. So if we have the net change and we want to get the rate of change, we get its derivative. Okay, so to get v as a function of t, we would have to get the derivative of dx over dt. So the derivative of 12 times e to the power of negative t times sine of t, we will get that 12 outside as it's a constant, and then we will get the multiplication rule, which is u prime times v plus v prime times u. Then and so we got the function as the function velocity. So this part is with no calculator, and this function looks kind of hard, and so you will need to remember the unit circle to solve it. So what is a radian that has the same value for cosine of t and sine of t, since both of them are multiplied with the same coefficients, but they have different signs. So when both of them are equal to each other, they would equal to 0. And this happens at pi over 4, which is answer A. And thank you. Here is another example about net change. This is question 82 from AP Calculus, AP from the year 2017 with calculus part. So let's start by reading the question. A particle travels a long line with velocity vt equals 3 times e to the power of negative t over 2 times sine of t2 meters per second. What's the total distance in meters traveled by the particle during the interval from t greater than or equal to 0 and less than or equal to 2? In this question, we see that they're asking about distance, not displacement. So, when we finding the displacement, we just find the integral from velocity. But for distance, we need to get the absolute value of the integral of the absolute value of velocity. Since to do that, we would have to find the x-intercepts from the interval 0 to 2 to check if we have to do to check how many integrations we need to do to find the total area. From this graph, we see that from 0 to pi over 2, the whole graph is above the x-axis, but from pi over 2 until 2, it's under the x-axis. So we need to do the integration again, but reverse the sign after pi over 2. So let's find. This is the integral of the function. It needs to be done with integration by substitution. But since we're doing, since this part is with calculator, we can just use our calculators and use these two, where Vt equals 3 times e to the power of negative t over 2 times sine of t2, to get a final answer of 2.261, which is the answer D. And thank you. We'll come back. This is question 2 from AP Calculus, AP 2016. This part is with calculator. Let's start by reading the question. For t greater than or equal to 0, a particle moves along the x-axis. The velocity of the particle at time t is given by Vt equals 1 plus 2 sine of t squared over 2. The particle is at position x equals 2 at time t equals 4. At time t equals 4, is the particle speeding up or slowing down? Well, from this graph, we have to read it. Do you see the point where it's certain 4? We have to draw a tangent line and see where the tangent line goes. See? This tangent line goes towards the x-axis. This means that it is slowing down. If the line was going away from the x-axis, this means that it is speeding up. And for part B, find all times t in the interval t greater than 0 and less than 2. When the particle changes direction, justify your answer. Okay, for part B, it's better to draw another graph using your graphing calculator. And we see that at point 2.707, it crosses the x-axis. This is the point where it changes its direction. So the answer for that question is 2.2707. For part C, which asks us to find the position of the particle at time t equals 0. Well, there's a formula where the function final equals the integral from the function from the initial to the final plus the initial, because we don't the initial place fills the place of the constant c. So in here we have x equals 4 as stated in the beginning of the question. It's equal to 2, I guess. Yes, it's equal to 2. So we do this. So we solve this integration for x of 0. And so we substitute everything inside, and we can see something, that this integration is not integrable. So we will just put it on our calculator to get the answer. So when we get the integration on the other side, we get 2 minus 5.815027, which gives us a final answer of negative 3.815. Now let's move on to part D. We have to find the total distance the particle travels from time t equals 0 to time t equals 3. Distance is the integral, the absolute value of velocity, as we stated in a previous question. So we would start off by the same way, drawing the graph. You don't have to draw the graph, you can just find the 0 on your calculator, but drawing the graph is better, I think, for visuals and trying to explain to you guys. Okay, so we see that from t equals 0 to t equals 3, the graph crosses the x-axis at t equals 2.707. So we would have to do two integrations. An integration from 0 to 2.707 minus the integration of 2.707 to 3 of the function. And we will get a final answer of 5.301. And thank you. This is question number 1 from the 2016 AP Calculus AP. Question 1 says, a company produces and sells chili powder. The company's weekly profit on the sale of X kilograms of chili powder is modeled by the function P, given by P of X equals 48x plus 1.4x squared minus 0.05x to the power of 2.8 minus 270, where P of X is in dollars and X is between 0 and 80 and it can equal them. Part A says, find the rate in dollars per kilogram at which the company's weekly profit is changing when it sells 32 kilograms of chili powder. Is the company's weekly profit increasing, decreasing? When it's 32 kilograms of chili powder, when it sells 32 kilograms of chili powder, give a reason for your answer. Well, we know that rate of change of any function is its derivative. So we got the derivative of the function of p of x, and we got a function of 2.8x minus 0.14 times x to the power of 1.8 plus 48. Now we would like to substitute 32, and we get an answer of 65.92, and this is the rate in which the profit is changing when it sells 32 kilograms of chili powder. And so, is it increasing or decreasing? Well, you see the number is positive. This means that an increase has happened, and so we will say it is decreasing at x equals 32. Let's move on to part B. How many kilograms of chili powder must the company sell to maximize its profit? Justify answer. For this question, we need to check our maximas. So we get the endpoints and any zeros in the derivative. The endpoints are at 0 and 80, and the derivative is equal to 0 at 58.358. And we can see that from the graph of the derivative. And now we can input these values or just graph them to see where we get a higher value, and we get the highest value at 58.358, and so this is the maximum. For part C, we get the question of the company plans to have a one-day sale on chili powder. Management estimate that T hours after the company's store opens, chili powder will sell at a rate modeled by the function S, given by S of t equals 2 plus cosine of pi over 10 t squared kilograms per hour. Based on this model, estimate the amount of chili powder in kilograms that will be sold during the first 5 hours of the sale. So we would like to integrate it to get the number from the rate of change. So we get this function and we try to integrate it from 0 to 5. But we can't find the integral of this since this function is not integrable. So we just input it in our calculator and we get a final answer of 11.43. And thank you. This was question number 1, 2016 AP Calculus.
I will solve question number 15 from the AP Calculus AB 2016. The question says a function ft gives the rate of evaporation of water in liters per hour from a pond where T is measured in hours since 12 noon. Which of the following gives the meaning of integral from 4 to 10 ft dt in the context described? It is B, which is the total volume of water in liters that evaporated from the pond between 4 p.m. to 10 p.m. because it asks for the total amount of water in liters evaporate from 4 to 10. I will solve question number 22 from the AP Calculus AB 2016. The question says a particle moves along the x-axis so that at time t more than or equal to 0, the acceleration of particle is at equal to 5 times under the root of t. The position of the particle is 10 when t is equal to 0, and the position of the particle is 20 when t is equal to 1. What is the velocity of the particle at time equal to 0? So, first, acceleration is equal to 15 t to the power 1 over 2. Then we should get its velocity, so we need to derive the acceleration to become integrate the acceleration, so it will become 10 t to the power 3 over 2 plus c. Then we need to integrate the velocity to get the distance, so st will become 4 t to the power 5 over 2 plus c t plus d. As given in the question, d is equal to 10, so it will be s t equal to 4 t to the power 5 over 2 plus c t plus 10. And then we will substitute st is 20, and so become 4, because 4 times 1 to the power 5 over 2 would give us 4, plus c, because c times 1 will give us c, plus 10. Then c will become 6. So Vt is equal to 10 times t to the power 3 over 2 plus 6. We will substitute t to 0, so it will become velocity at time 0 is equal to 6, which is D. I will solve question number 2 from the free response of the test AP Calculus AB 2017. The question says, when a certain grocery store opens, it has 50 pounds of bananas on a display table. Customers remove bananas from the display table at a rate modeled by FT, where FT is measured in pounds per hour and T is the number of hours after the store opened. After the store has been open for 3 hours, store employees add bananas to the display table at a rate modeled by GT, where GT is measured in pounds per hour and T is the number of hours after the store opened. So I will solve the questions which are related to the change, which are A and B. First of all, we will start with A. How many pounds of bananas are removed from the display table during the first 2 hours the store is open? First of all, A, we should find the integration from the integral, from 0 to 2 hours ft as calculator are allowed for as calculator is allowed for this type of question. So using the calculator, the answer will be 20.051 pounds. Then B, it says find f prime 7 using correct units, explaining the meaning of f prime 7 in the context of the problem. Okay, so B, f prime 7, again using the graphical calculator, it will be negative 8.120 pounds per hour square. And for explaining it, it is the rate at which bananas are removed from the display is decreasing by 8.20. It's decreasing because it gives us negative answer. Pounds per hour again. That's why it's pound per hour square at t is equal to 7. Again, the rate at which bananas are removed from the display is decreasing by 8.120 pounds per hour at time equal to 7. That's all.
Hi, my name is Maid. I'm from 12.1 and today I will explain my task my task about the project for term 2, and my task is explaining and solving net change and motion problems from AP 2016-2017. And first of all, I'll explain what's the net change and motion problems. We know that the integral of the rate of change of any quantity gives the net change in that quantity. Okay, this we have to know, or this is the meaning of net change and motion. And we know that here we have the xt, it is distance, and here vt, it is velocity, and here at, it is acceleration. Okay, here from if we have the distance and we want the velocity, we do derivative. Okay, and if we have velocity and we want distance, we do integration. And the same thing here, if we have velocity and we want the acceleration, we do derivative. And here, if we have acceleration and we want velocity, we do the integration. And if we have velocity and we want acceleration, we do double derivative, and here double integration. And the rule of the distance, velocity, and acceleration. Okay, here we have a question from the AP 2016. Question number 83. Okay, the question said a particle moves along a straight line with a velocity given by vt equal 5 plus et over 3 for a time from a time t greater than or equal 0. What is the acceleration? From particle t equal to 4. Okay, we know that, and now we know that if we have a velocity and we want acceleration, we do what? Derivative. We do derivative for this, so we do derivative here, d over dt of 5 plus e t over 3. We know that the derivative of this is 0, okay, 0 plus, and here the derivative of this e t over 3, the same over 3. Okay, and now we substitute here t equal to 4, so will be here e 4 over 3 over 3 over 3. If we calculate the answers, will be 1.265 and from the answer it is see here C, it is C. And this question, and we will solve now another question. And now you solve another question, question of also 2016, and it is question 89. Okay, here we have a graph. The question says the particle move along a straight line for a 6-second so that the velocity in centimeter per second is modeled by the graph shown during a time interval 0 to 6 with the total distance the particle travel. Okay, here we have the graph from 0 to 6, and first of all we know that if we want the distance, we have the area under the graph. Okay, here we can divide the area from 0 to 2, or let us draw it here. It's like this, straight here, like this. Here you can see 1, and here is 2, and here 1, 2, 3, 4, 5, and here it is 6. Okay, and here VT, the velocity, and here the time. The graph is shown that from here 2 is straight, and from 2 to 3 it's going down. It's going down here and moves in straight line till 4, and from 4 to 5 it's by negative, and then it is straight. Okay, here, and now we can divide the areas. Here till 2, sorry, till 2. So here will be 1, here 2, and this we make it a straight line, so this will be 0, and here also, and here. So here 3, and here 4. Okay, and now we know that here xt, the area under graph. Okay, area under graph. Here area of square, here area 1 equal area of square, it is side by side, so 2 by 2, 2 times 2, it will equal to 4. Okay, and here of area 2 equal and it is an area of the triangle, so half base by height. We have here we have half, the base is 1 and the height is 2, so 1 base, the height is 2, so the answer will be 1 here, centimeter, and from 3 to 4 it is 0, and here area 3, it is equal to also area of triangle, base height half, the base we have 1, also here negative 1, so also the height is 1, so it will be half centimeter, and the last one here of square area 4 equals side by side, and it is 1 by 1 times 1, so it is 1 centimeter. And now the total area, or we can say xt equals we get here 4 plus 1 plus half, and here plus 1, so we will get here 5.5, 6.5 centimeter, and here from the 6.5 centimeters take the distance taken from 1 to 6 seconds, and it is answer D from the multiple choice. And thank you. Here on free response question from 2016. Question number 1, free response. The question said, water is pumped into a tank at a rate modeled by this equation, liter per hour for 0 to 8, where T is the measured in hours. Water is removed from the tank at the rate modeled by RT, liter per hour, where R is differentiable and decreasing in from 0 to 8. Selected value RT is are shown in the table above. At T0 there are 50,000 liters of water in the tank. Here we have the table 0, 1, 2, 3, 6, 8, and here the liter per hour 1340, 1190, 950, 474, 740, 700. We have for the net change we have only to solve B and C. B says that use a left Riemann sum with the 4 sub-intervals indicated by the table to estimate the total amount of the water removed from the tank during 8 hours. Is this an overestimate or underestimate of the total amount of water removed? Give a reason for your answer. Okay, first of all we hear number 1 B. Okay, first of all we have to do the Riemann sum. The total amount of water removed. So here the integration 0 R T dt. Okay, and this equals to the difference from this 2 is 1, so 1 multiplied by 134 plus 3 minus 2, 1 is the difference is 2, and here the left 1190, and here the difference 3 950, here the difference 2 740. Okay, first of all we say that the 1 times 1340 plus here the difference is 2 times 1190, and here plus 3950 plus 2 times 740. Okay, here we calculate by the calculator. Wait a second. The answer will be 8050 liters. Okay, this is the overestimate since R is decreasing function. Okay, here we calculate the left Riemann sum. And now for C, use your answer from part B to find an estimate of the total amount of water in the tank to the nearest liter at the end of 8 hours. Okay, now we know that here C, the total, okay, and as we say, we know that there is initial 50,000, yes, 50,000 plus the integration of the integration from 0 to 8 for this one. This is the total for the total water. So integration from 0 to 8 to 1000 E negative T squared over 20 minus the answer that we have here, 80 50. Okay, now we calculate here 50,000 plus we calculate this one. Wait a second here. Okay, 5836.19535, and here minus 50 will be 49786 liters approximately here, because it will with decimal and you have to get the whole numbers. And this is the whole question.
Hi, I'm Mohammed Abid and I'm going to solve my required questions for Term 2 project according to my objective, net change and motion problems. The first task is to classify the questions of the net change according to the AP College Board exams of 2016 and 17. As you see here, the questions have been classified for both exams 2016 and 17, multiple choice and free response. The second task now is to talk about the topic and give information about it. The third task lately, we will do questions and solutions from the actual AP 2016-17 exams. First, let's talk about the topic in general. It deals mostly with displacement, velocity, and acceleration. It's integrating a quantity to acquire another quantity related to it. It doesn't only talks about displacement, velocity, and acceleration, also other quantities, but mainly these three quantities. We know that displacement is dt, and the velocity is vt, and acceleration is at. So let's see how they are related. If we have a function as a displacement function, and we are required to find the velocity function, we just simply, if we are moving like this, we simply derive. And if they give us a velocity function and they want the acceleration function, we just derive again the velocity function. And if they give us the displacement function and they want the acceleration function, we just simply derive twice. And if we want to move in the opposite path, we just simply from acceleration function to velocity function, we integrate. And from velocity function to displacement function, we also integrate. And if we are required to find the displacement function from an acceleration function, we simply integrate twice. If they give us a displacement function and they want a velocity at a certain time, we simply substitute the number of the interval in the integral to find the exact velocity, not the velocity function. So let's take some examples. The first example is to find the velocity from to find the displacement from a velocity function. So find the displacement from a velocity function. So we are moving like this to this, so we need to integrate. But they don't want the displacement function, they want the exact displacement, so we need to substitute a time interval. So the question is, suppose the initial position is as of 0, the position. Here it can be displacement, position, or distance, but distance cannot be negative. So we deal mostly with position, so it can be a negative answer. So the question says that the initial position at t0 is 9. What is the particle's position at time equal to 1? Okay, so now we need to find the position of the particle at time 1. And we only know that the initial position at t0 is 9. And we will use this equation, which is v of t, velocity function, t squared minus 8 over t plus 1 squared. So they gave us this velocity function, and we are required to find the displacement at t1. So we need to integrate. But we should first know what is the time interval. The time interval here is from 0 to 1. So, because they want us to find at t1, and the initial is of course 0. So the displacement is equal to the integration from a to b of the velocity function. So the integration from 0 to 1 of the velocity function, which is t squared minus 8 over t plus 1, both squared. After doing the integration, we'll find that the displacement will be equal to minus 11 over 3. But we need to do something. We need to add it to the initial position. So we need to add the initial position with the 9. Or we can add from the beginning 9 plus the integration. It's the same, no difference. We will have 16 over 3. This will be our displacement. Another part of the lesson of net change is calculating the total distance. It's the same thing, so we just make displacement is equal to the integration, but what's the difference? That we take not the v of t as before, we take the absolute value of the velocity function. That's another part of the net of change lesson. And also another part is modeling the acceleration. So let's take an example. A car moving at velocity 5 mph and accelerates at rate a of t equal to 2.4 t. Now that's an acceleration function. mph for 8 seconds. So how fast is the car going when 8 seconds are up? They want the velocity, so we need to integrate the acceleration function. V of t is equal to the integration from a to b, a of t dt. So v of t integration, as they said, that the time is 8, so it's from 0, which is the initial, to 8, the function of the a, which is 2.4 t dt. Integrated, just add 1 to the power and divide by 2. So velocity is 1.2 t squared from 0 to 8. After substituting the number, we will find the velocity is 76.8 mile per hour. So this is an information about the topic of the net change and motion problems, and in the next video we'll start solving AP questions from the exams of AP College Board 2016 and 2017. Hi, now this is the second video for solving this is the first video for solving for AP questions, but the second video for all the videos about the net change, which is the task 1, 2, and 3. Now in task 3, question and solution for topic 3, which is net change and motion problems. The first question is question 5, multiple choice question from the year 2016 AP College Board exam. The question is, water is flowing into a tank at the rate R of t, where R of t is measured in gallons per minute and t is measured in minutes. The tank contains initially 15 gallons of water at time equals 0. So we know at t equals 0, we have 15 gallons. Value for R of t for selected values of t are given in the table above. Using trapezoidal sum with 3 interval indicated by the table above, what is the approximation of the number of gallons of water in the tank at time 9? They want the gallons when t equal 9. How many gallons? They gave us a hint how to solve using the table, which is using the trapezoidal sum. They want, first we need to make the equation of water flowing of gallons. We can call it W of T. It should contain the initial gallons, which is 15, plus the integration from 0 or A to B, and then R of T dt. They didn't give us a function, but they gave us a table, and they also told us that we used trapezoidal sum. So this is using trapezoidal sum. So let's use it here. As it's shown here on the table, we need to find the number. So trapezoidal is equal to 9 plus 6 divided by 2 times from 0 to 4, so times 4 plus 6 plus 4 divided by 2 from 4 to 7, which is 3, so times 3 plus 4 plus 3 divided by 2 times from 7 to 9, which is 2, so 2, and we will get 52. Okay, so let's write the equation again. T equal to the initial gallons plus the integration, which is 52, and they gave us the initial, which is 15, so 15 plus 52, which equals 67 gallons. So we simply know that it is 67, which is so choice C. We finished the first multiple choice question. Now let's go to question 79, multiple choice question of exam AP College Board 2016. The question says, the number of people who have entered a museum on a certain day is modeled by function f of t, where t is measured in hours since the museum opened that day. The number of people who have left the museum since it opened the same day is modeled by a function g of t. If f prime t is equal to 380 times 1.02 power t, and g prime t is equal to 240 plus 240 sine brackets pi t minus 4 divided by 12. At what time from the interval 1 to 11 is the number of people in the museum at a maximum? We simply understand from the question that f of t is the people who entered, and g of t is the number of people who left. And what we want to know is the maximum number of people. And we know the number, we can make an equation for the number, the rate of number of people is equal to the integration from 1 to t. T will be changing because I'll tell you later why, what's the reason. So f prime of t who entered minus left, so we can know the remaining, times dt. Since they say to us that the time is from 1 to 11, so we need to see if at what time between those two intervals it changes. So we can make a table that can start with 1, and then let's say maybe 3, 5, 7, 9, and 11. Let's see. First, and here is the t, and here the number of people. At time 1, we substitute simply 1 to 1. So let's just write the function so it will be more clear. 1 to t. What's the function of this one? Is 380 1.02 t minus 240 plus 240 sine pi t minus 4 divided by 12 dt. So the first time is 1. 1 to 1 is 0, simply. And let's see the maximum. If we substituted 11 using the calculator, we will have 1000.917. First, just let us look at the choices. We have 1, 7.88, 9.446, 10.947, and 11. And we want to know the maximum number of people at what time. So instead of doing this, actually we can just substitute the numbers that's given in the choices so we can know. 1 is impossible, so we just simply cross it. And then now just let's take us 7.888 and 9.446, 10.974, and 11. So we know that 1 is 0, and for 11 we substitute in the calculator, we got 1000.917. And when substituting the calculator 7.88 from 1 to 7.88, we have 1040.535. And if we substitute 10.974, we get 1000.909. And if we substitute 9.446, we get 1012.321. So, as we see here, from the time interval 1 to 11, and from the choices that I've given, the maximum is at 7.88, which is 1,400 people, 40 people. It's more than 1,012, 1,000, and 1,000 also, and 0. So the maximum at time 7.88, where we will have 1,040 people. Hi, this is the last part for solving questions and solutions for the topic 3, net change and motion for AP College Board exams 2016-17. This is question 84 from year 2016. The question says, a home uses fuel oil at a rate R of T equal to 10 plus 8 sine T over 60 gallons per day, where T is the number of days from the beginning of the heating season to the nearest gallon. What is the total amount of fuel is used from T equals 0 to T equals 60? This cannot be easier. They want the amount of fuel from 0 to 60 days. So I just call it F of T. And we need to integrate this equation, the rate, to find the fuel rate. R of T dt. And couldn't be easier that they gave us already the limits from 0 to 60. So 0 to 60. So F of t is equal to integration from 0 to 60. The function is 10 plus 8 sine t over 60 times dt. And now f of t, let's see the answer in the calculator. The integration from 0 to 60, 10 plus 8, so 10 plus 8 sine of t over 60, simply like that, like this. And also we can also find the amount of fuel that is used from T0 to T60 by finding the integration, since the integration is easy, not that hard, but you can use the calculator as an aid to help you find the exact solution. So the integration is, as here, 10x plus, we just take the 8 times 60, 8 times 60 outside, so it will be 400. Sorry, it's sine, so the integration is minus. Then 60 times 8, 480. Cosine t over 60 from 0 to 60. F of t is equal to 10 times 60 minus 480 cosine 60 over 60, which is 1, minus 10 times 0 minus 480 cosine 0 over 60. F of t, let's see in the calculator. It will be 800. The answer will be 821. So we have 7, 14, 600, 821, 1004, and we got 821, so 821 is the answer. Just let us check by the calculator using the just putting the integration immediately, so we just check the answers correct. 10 times 16 minus 480 cosine 60 over 60 minus minus 480 cosine 0 over 60. We get 820.65. The closest is 821, so just put 821. The last question, which is from the AP exam 2017, question 84. So the question is 1 minute. Let me open the exam. It's about bacteria mainly. So 84. The question says that if we have 1000 bacteria at time 0, what is the number of bacteria that you will find after the time t equals 3? Okay, so we know the initial. they want the amount of bacteria, B of T, let me see. As they give us the initial, as we did in the previous, R of 0 plus the integration from A to B of what? R of T times dt. The rate of bacteria, they give us the initial as 1000 plus the integration. We start at 0, so 0, and they want us at time 3, so 0 to 3. R of T, since we have no function, times dt. And the only question that also, the only answer that's given is the part D. Also, if you don't know how to solve this, depending on the options that you have of the answer, you see that you have the initial is 1000. And of course we use the integration. The only choice that gives you the option to add 1000 as an initial is part D. So this can be also makes you feel easier to solve, which can be considered as an easy track. And this is all the questions for the Term 2 project from AP College Board Exam 2016 and 2017. Thank you.